Hello, fellow humans, and welcome back to Beyond Words, where we explore the science of language, music, and the mind. Today's episode is with someone who really changed the game, Dr. Jenny Saffran. Back in 1996, she published a landmark study showing that infants can track patterns in speech, a process called statistical learning, long before they say their first word. Since then, her work has reshaped how we understand language acquisition, cognition, and even what it means to learn. So in this conversation, we dive into how babies find words in the chaos of sound, how physical environments can support language learning, and what it really means to know something before you can say it. So whether you're an SLP, someone who loves CogSci, or just someone who's curious about how minds grow, you're going to really love this one. Let's dive in. Beautiful. Well, hey everyone, super excited to welcome you to my new podcast. It's called Beyond Words, Conversations on Language, Music, and Mind in collaboration with Speech Therapy PD. And I'm your host, Garrett Oyama. I'm a musician, practicing SLP, and a PhD student with an interest in all things language, music, and cognition. And I'm super excited that we have the one and only Dr. Jenny Saffran here, who's really such a pioneer in our field. Just a little bit about her. She's a professor of psychology at the University of Wisconsin-Madison and a renowned cognitive scientist in the field of language development. She directs the Infant Learning Lab, where she studies how infants learn to segment, categorize, and make sense of the continuous stream of sounds in language. Her pioneering work on statistical learning has really transformed our understanding of how babies acquire language from birth and even before. So before we get started, just a few items to mention. So most of these upcoming podcasts, including today's, will include a speech therapy PD course that's available for 0.1 ASHA CEUs. And just a couple of disclosures, we both get compensation from Speech Therapy PD for this podcast, but there are no other relevant non-financial disclosures to report. So without further ado, Dr. Saffran, welcome to Beyond Words.
Thank you so much for having me, Garrett. I'm especially excited knowing that you are not only a language person, but also a music person. So am I. I think a lot of musicians gravitate towards studying language and vice versa. So it's kind of cool.
Yeah, there's such a deep, intimate connection, right? With organized sound. In fact, I'm actually talking to next week. I'll be speaking with Dr. Daniel Bowling, who's the Stanford Brain and Health Sciences lab head. And so we'll be talking about that connection a little bit more.
Cool.
Yeah, is that part of the reason why you got into language? What's your origin story with this whole thing?
It actually is exactly why I got into language. I have a longer origin story, but the shorter version is I started my first ever baby studies, how babies learn studies were actually about music perception because like you, I'm a musician and I was really curious whether infants perceive and process music in sort of ways that are similar, or whether we could take the methods that people had used to study how babies process language and use them to study how babies process music. So I actually started doing that sort of work as an undergrad, and then ended up gravitating towards language for a couple reasons. One was that at the time there was pretty much no funding for research on the psychology of music in the United States. And the other was I was super interested in the degree to which our learning abilities are tailored for specific purposes, like learning about language or learning about music, or whether they are sort of more general. And so I thought that comparing language and music would be a really great approach.
That is so cool. I didn't know that. This might be getting into the weeds too early, but I was speaking with Dr. Deutsch, the auditory illusions
Sure.
professor recently, and we were talking about the category boundary that might form. And this might be related to statistical learning stuff, but given that music and speech are just organized sound and there's kind of like a spectrum of that kind of shades into each other. At some point though, you pick up on these context clues that kind of switch you from speech to, oh, I'm hearing music all of a sudden, which is kind of shown in the very famous auditory illusion where you start to hear this phrase repeated over and over again in speech. I think it's like, sometimes behave so strangely. And after you hear it a certain number of times, it suddenly flips to, hearing the melodic aspects of the sound. So I was just wondering, if there's a point in infancy where this category boundary develops? Or I don't know. Do you have any
It's a,
thoughts on that?
I think it's a really deep question. I mean, do babies start out so treating music and language as distinct things, or do they have to figure out that some of this stuff that is sort of has pitch and loudness and frequency and all, some of it is communicating information in one way, and some is communicating information in another way. And then, of course, complicating it is that some languages use pitch in really particular ways, where pitch is like deeply embedded in how language works. In languages like English, pitch is a little less relevant. And so babies, if you're learning a language like Mandarin or Thai, like you have to learn about how pitch works in a totally different way than a baby learning English. And so I'm fascinated by those questions. I don't think we really know if and when, I mean, we know babies eventually start to sort of, okay, this is music, this is speech, but we don't know a lot about kind of when and how that starts.
Yeah, it's so deep. And it might relate to your, statistical learning research, because basically you've shown that taking out, from what I understand, at least in the stream of sounds that you show these infants, there is no pitch information really that's kind of differentiating one sound from another. Is that what you were going for there? Kind of taking out the musical aspects of...
Yeah, in our very first experiments, we took out the musical aspects because we wanted to sort of isolate cues like statistics, like the fact that certain syllables tend to predict one another and go together, and see if infants could make use of that information when you strip away everything else. In subsequent work, we did add back in things like pitch and rhythm and other sorts of cues to see how babies might integrate them. And we've similarly done studies looking at how babies track the statistics of musical stimuli. So do they keep track of the fact that C follows F and F follows G, or that minor thirds are followed by perfect fourths? So we've sort of gone in all sorts of directions around the question you just asked.
That's so cool. Maybe, would it be okay for all those people that maybe have not heard about this work, if we could just like
yes,
backtrack a second?
I was thinking that too.
Yeah, and just talk about maybe that first, the 1996 paper, kind of the first statistical learning paper, when we realized that babies weren't just cute, but these, computational geniuses tracking probability patterns.
To be fair, I think people in our field had known that babies were, pretty darn good pattern detectors for a long time. But what was fun about this work was that we came up with a way to really demonstrate it in the lab. So the problem we wanted to tackle is something that faces all language learners, which is that we don't talk like this. So there's no pauses between the words in continuous speech. That's true even when we're talking to babies. It's true in all languages, presumably. I haven't studied in all languages. And it's a really interesting problem because it's something babies have to solve in order to do the rest of language acquisition. If you can't figure out that pretty baby is 2 words and not 1 word or 4 words, you're kind of stuck. So that was the problem that we set out to try to study.
Amazing. Well, the illusion of sort of these spaces in between words, I remember learning about that in grad school, actually, and just kind of having this moment of, oh, wow, yeah, we're really, there's this sort of undifferentiated mass of sound coming at you, and your job as an infant is it's a pretty big one to try and figure out where all those gaps go. And also, this further problem of how do you measure stuff with babies?
That's the fun part. Yeah. So, I mean, I think the problem is a particularly fun one because, right, as native speakers, it is an illusion. We do think there's pauses between words, just like the little spaces on the page. But it's also very easy to realize that there aren't. All you have to do is sit on the bus behind someone speaking Russian or any language you don't speak, and you quickly realize that it just sounds like blah 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 blah, and there are no words. And so I always find it fun when I'm teaching about this to ask students to raise their hand, and if they speak a language that most of the people in the class don't speak, just talk and have the rest of us turn into babies. So there's this interesting problem, and the solution that we explored in the paper you talked about is one solution that seems on the face of it to be really unlikely, and that is that these little squishy babies are actually doing math. And maybe it doesn't seem as surprising now in this world of large language models, and you were sort of immersed in a lot of this computational work now. But at the time, it seems sort of surprising. So maybe part of how babies figure out where one word ends and the next one begins is by keeping track of statistics, namely which sounds tend to go together. So if we use an example like pretty baby, how would you figure out that there's a break between pretty and baby, and that it's not that pr is a word and t is a word? Well, t is actually a word. And one way you could figure it out is by noticing that when you hear the syllable pr in English, it tends to be followed by a very small set of other syllables. In English, it's followed by t, like pretty, or tend, pretend. There aren't a lot of others. There's predilection, prevaricate, words most babies don't hear. And so the intuition is, okay, if you hear pra and you wanted to make a bet about what's coming next, T is a pretty good bet. But when you get to T, what comes after T? Well, kind of anything, right? Because we could have pretty shoes, pretty sunset, pretty dress, pretty cake. And so if you are doing the math, there's like a big dip from T to what your bet would be for the next syllable. And so we hypothesized that maybe part of how babies figure out that some sounds cohere together into words and other sounds do not cohere together into words is by doing precisely that sort of statistics. And so that was the intuition. And before I tell you about how we studied it, any questions or observations about that?
I mean, it's just incredible. I've always wondered how you came to that intuition. Were there other paradigms that were studying statistical learning in other fields, and so you kind of were like, okay, this seems like it might be relevant here, or was it? Yeah, how did you come to that?
It
Yeah.
was there are actually a few sort of converging disciplines that pointed to something like this. One is actually linguistics. So back in the 1950s, linguists who were known as structural linguists, who were sort of going to other languages and trying to figure out their structure, had pointed out that in fact, the sounds that are part of a word tend to travel together. And so they didn't talk about it as a statistical learning process, but if you think about it in the visual world, think about like how you would tell your listeners can't see me, so it's probably no use for me to gesture this way, but think about an object moving through the world. The pieces of the object tend to travel together through the world, and that's part of what tells you as a learner that those are part of the same object. So
Mm,
if you pick a cup off the table, the fact that the cup moves separate from the table tells you they're part of different objects.
mm,
And the same is true for words. The pieces of words that are part of the same word move together. Pieces that are part of different words don't move together. So that was something that linguists had been talking about for decades. Um, the other thing that was happening was researchers in sort of computational fields had started to sort of really plumb the statistics of language. And there was in the early days of the computational modeling that has led to large language models and AI. And because of the availability of sort of lots of data, I mean, not like lots of data now, but sort of bigger data sets, they had been starting to show that in fact you could sort of see, if you do statistics over big data, that there are patterns that live in those data. And so there were these really nice fields that were sort of coming together. And I think our contribution was to say, let's see if we can figure out if babies actually do this. So this information seems to live in languages. It could be really helpful, but it's only helpful if babies can actually track statistics. And that seems maybe unlikely because babies don't seem to be like the brightest, right? On the other hand, we know that one of the things that human brains, actually all brains, not just human brains are really good at predicting stuff and kind of figuring out what goes together. That's part of what lets us survive. And so on the other hand, we thought, well, maybe it's not crazy. Maybe brains are actually good at keeping track of this sort of stuff. And we did know from vision scientists that there had been a lot of work looking at sort of learning about visual properties and their
mm.
statistics, not in babies so much, but so it on the one hand seems sort of crazy, on the other hand it seemed, why not? We can try this.
Yeah,
So we
so
tried
cool.
it with adults first, and then moved to babies. Um, we uh, what we did, which you alluded to, and talking about music a few minutes ago, was we exposed babies to a made-up language. This particular language only had 4 words. I am the only native speaker of this language, and the words are meaningless to anyone but me. There are things like golabu and pabiku and paduti, things like that. And we strung them together, 2 minutes worth of these words using a speech synthesizer that didn't know where the words began and ended. And so it just made a monotone rhythmic stream that sounded something like this. Gola bu pa bi ku tu ti bu ba bu pu gola bu piga ku ba du pu, like just literally for 2 minutes like that. Um, and unbeknownst to the babies, there's structure. So still the 3 syllables go la boo tended to go together. If you heard go, it would be followed by la, and then la would be followed by boo. That was a word in this language. Um, and so if babies were sensitive to these co-occurrence statistics, then they might have an opportunity to actually like pull out go la boo as a possible word and treat it differently than something that goes across a word boundary like let's see, pigola or something like that. So
Yeah,
we exposed
yeah.
babies to this for a couple of minutes. We got them bored, and then we tested them to see what they learned. And this is where it gets kind of fun. How do you ask babies what they learned, right? That's the hard part.
Yeah.
So, yeah. So, what we did in this particular study was we took advantage of a nice factory installed feature of babies, which is that they like to listen to familiar things until they hear them too much, and then they don't want to listen to them anymore, called habituation. Um, and so this is going to be hard to explain without visuals, but basically on each trial, so for the first 2 minutes, the babies just sit on their parents' lap and they hear go la boo pa bi ku tu ti boo ba boo poo, just this 2 minutes of speech. Then the room goes silent, and they're in this particular setup, we use little lights to capture babies' attention and measure what they want to listen to. So the room goes silent, and a little light in front of the baby starts to blink just to get their attention, make sure they're not trying to eat their socks or whatever. When the baby's looking at that center light, the experimenter who's outside of the room triggers a light on one side or the other. So a light, say, on the left side is going to start to blink. When the baby turns her head to look at that light, they're going to get to start to hear a sequence of sounds from the language. So they might hear go la boo, go la boo, go la boo, go la boo, and it keeps playing as long as the baby keeps looking in that direction. When the baby looks away, the center light starts blinking again until it's silent, until the baby is looking at the center light, and then one of the side lights will start to blink. And when the baby looks at that, they'll hear say, pigola, pigola, pigola. The way this works is the baby is the boss. So the baby controls how long we play each stimulus. Um, and then what we're interested in looking at is their attention to and interest in sequences that were words in the little language, like golabu, that has the statistics of a word. The syllables tend to go together, versus a sequence that went across a word boundary, sort of like T-Bay in that pretty baby example. Um, and we'll measure how long the babies listen to these 2 different types of stimuli. And then, as you have alluded to, it works, right? So babies, it turns out, in this sort of paradigm, um, because we've gotten them bored of this stimulus, will actually listen longer to the sequences that violate the structure of the language. So they'll
Mm.
listen longer to the stuff that goes across the word boundary. And what that tells us is that the babies learned something. So they didn't just get used to the individual syllables, they learned something about which syllables tend to go together. So they seem to be tracking something about the properties of the language they've been listening to.
Yeah, it's so incredible. Do you think that there's, or in your research, did you see much individual difference in kind of the formation of these? To clarify a little bit more, like, do you think that some kids are, you know, like there's a normal distribution of kids who are like good at forming these patterns and then like maybe take longer to identify these statistical regularities? And is there an optimum? Like I can imagine, for example, that it might even be worse if you were forming those patterns too quickly because you
Hmm.
can pick up on the wrong ones, right? Because that if you
Hmm.
there are some times that T and
Hmm.
Bay might go together like
That's right.
accidentally.
Right.
So
Like a spurious correlation. Yeah.
right.
Yeah, that's a great question. So, in this particular infant method, we can't really look at individual differences because honestly, it's too fragile. So, a baby might show a particular preference because, maybe they're getting a little crabby and they need a nap, or they're a little hungry. Like, I wouldn't want to interpret an individual baby's data in this sort of paradigm.
Mm,
But we and others have done work looking at children and even adolescents who have different ranges of, say, native language skill, or who have a developmental disability that impacts language acquisition. And in those cases, we do see individual differences that are correlated with performance on these sorts of tasks. So, children with developmental language disorder, for example, do more poorly on these statistical learning tasks, both linguistic ones and non linguistic ones, interestingly. Children and adolescents with dyslexia do more poorly on these sorts of tasks as well.
mm,
So there does seem to be, but interestingly, some other developmental disabilities like autistic children as a group don't necessarily do more poorly unless they have language challenges. So
mm,
the abilities and sort of the language domain do seem to travel along with the statistical learning task performance, at least as
mm.
measured um, with older children and adolescents. Unfortunately, the infant tasks are just not from other people do interpret individual infant data on these tasks. I don't think that's a good idea. So we look at group data primarily for the infants.
Interesting. Yeah, what made me think of that was I've spoken a lot to Nina Kraus once early
Hmm.
on
Oh,
this
yeah, great.
podcast,
Hmm.
and yeah, she's awesome. And she's mentioning some of the research with regards to dyslexia, and in older kids, they're tracking kind of the FFR, which is
Right.
the EEG measure of their, I think it's a auditory brainstem response, which kind of
Hmm.
tracks, sees how good they track a sound, at these basic levels of
Yeah.
auditory processing. And they showed that there was actually just heightened levels of plasticity in the,
Mm.
so dyslexic individuals, when they're older, for example, they can actually do certain things better because of the plastic nature of their response. Like,
That's cool.
so for like Japanese people, like the R and the L, like, it's hard to tell a difference, right? Because you form these category boundaries that are in different places than in English. But dyslexic individuals can actually learn to shift that boundary later
Hmm.
than other people. So I was just wondering about
That's
this, like
interesting.
maybe that there's this sort of optimal range for statistical learning for kids, where they're kind of optimally forming these patterns, not too quickly or not too slowly.
Yeah, that's really interesting. I mean, I think the interrelationship between that question and sort of the amount of data that you need in real languages is very interesting. So in the kinds of tasks that we do, we only have 2 minutes to test these kids. So we give them really simple structures and very little data. And so there's not really a great opportunity to sort of pick up on spurious kinds of patterns. But you're absolutely right that in natural languages, there's huge opportunities, right? And we know that kids, like even in this domain of figuring out where words begin and end, like is cat is a word and category is a word, but that doesn't mean agory is a word, right? But you could pick up on that spurious kind of statistic and think agory is a word. In fact, there are great stories. I don't know if this is true, it could be apocryphal, but there's a great language development story that I tell in my classes where the parent says to the kid, behave, and the kid says, I am have. Right. I mean, that makes perfect sense statistically, right? Like be and have are different words, right?
Yeah.
So have should be a word. But I don't know. It would be interesting to try to get kids to pick up on those spurious patterns in the lab. That would be kind of cool.
Yeah. Yeah. I wanted to ask a question too, what you thought about what's happening neurophysiologically, like when, they're forming these statistical patterns. It seems like kind of, the basic Hebbian plasticity.
Right.
You're grouping these things. You're sort of, I guess, if you hear the sound stream, pabiku, golatu, and
Good job.
is that right? I think this is correct.
It's close
Close
enough.
enough. Yeah. So through probability, they're fire, like certain groups of neurons are firing, and then they're kind of maybe those groups are becoming more frequent. Like these neurons are firing together more frequently,
Mhm.
and then over developmental time, those become stable.
Right.
Like with understanding that they go with certain actions, or with certain in certain contexts and things like that. And then, do you think that that sort of statistical learning happens at these kind of higher contextual levels, so to speak? So, like
Mhm.
grammar patterns and narrative
Yeah.
patterns and all of these things.
Probably. I mean, that's again what large language models do, right? So large language model, like, when you go into ChatGPT and it produces this beautiful syntax, all it's doing is predicting which word comes next, right?
Yeah.
So with enough data, there it seems pretty clear that you can find, I mean, those models, they certainly write better than a lot of my undergraduates do. So, they're doing well. Um, we don't know a ton yet about exactly sort of which levels of analysis babies and little kids are able to track statistics at. We do know they can certainly track the patterns of words, which words tend to go together. And we think that they can track structures of like which types of words go together. So different categories of words, meaning categories or grammatical categories. And I've done some work on sort of basic syntactic learning based on statistical properties. How far we can go, can it explain everything? I have no idea. I mean, it seems like it probably can at scale, like like ChatGPT, but of course, babies don't get that kind of, babies don't need massive like energy farms in the desert to give them enough
Yeah.
energy and power to to learn a language, right? They just get what they get. But it is
Right.
interesting. I mean, you're talking about sort of firing together and wiring together the Hebbian learning. One thing we have looked at is sort of what's the fate of these sequences? Like, are they really words for babies? And what does that actually mean? Um, and it turns out that they kind of do seem to change, like be treated by babies. Like Gola Boo becomes a unit. It becomes something that's available for mapping to meaning.
Hmm.
We've done studies where we've given babies first a training like the Gola Boo Pabi Tuti Boo, just the sequences of syllables. But then instead of testing them with blinking lights, we give them a word learning task where now some of the words are actual words from the fluent speech, like golabu, and some of the labels are sequences that go across word boundaries, like pigola or tibe from the pretty baby example.
Hmm.
And they're mapped to labels and mapped to objects. And we ask whether babies are better at mapping labels to objects when those labels had good statistics in the fluent speech. And they are. So even when they've heard Golabu and Pigola equally often. If Golabu has better internal statistics, that is, if the syllables predict each other more strongly, babies are better at mapping that sequence as a label for a new object than a sequence that has weaker internal statistics. So they do seem to be kind of going from the syllables to the words, for sure.
Oh wow, that's so interesting. It's interesting to think about that, the visual and the auditory analogy also that you were talking about before, because it's like I just always thought in doing speech therapy, it's so difficult to learn things that you can't see and that disappear really,
Mhm.
really quickly.
Yeah,
We're so visually kind of attuned, and it's such a I don't know what's the word. They like kind of the dominant sense,
yeah,
and things stay there. But
yeah,
when you have language, it's just things that are happening so fast. It's like, how do
yeah.
you form an object? Like it seems obvious to us, like we see an object. Maybe it's not so obvious. We like as an infant, maybe you're kind of doing this statistical stuff with light information, maybe, or something like that. But yeah, yeah, it's such a cool thing to think about that, they're sort of forming these objects together.
Yeah, it's cool.
Yeah. Well, and also that this has a lot of implications for speech therapy because, I talk to a lot of parents and they tend to think that language and speech, it just sort of, it's supposed to emerge. It's like, teeth or
Hmm.
hair or something. Why isn't he
Hmm.
talking? It's just, you need
Yeah.
to, um, you just needs to figure out something with the mouth or something like that. But I think a lot of this research really points to the fact that, input's pretty important because they do need the
Mhm.
input to figure out what those regularities are. Is that right?
Yes, and I think what you're pointing to is another really important thing that maybe is it's just harder for parents, but what your kid understands and knows is vastly greater than whatever's coming out of their mouth, right? And so I think that's another really important aspect of all of this is before that production can ever start happening, there's all this learning that has to happen. And so even when we're for both clinical populations and for children with typical development, I kind of object to the use of the term nonverbal because it implies that they don't know anything. But for all we know, they know a lot. And in fact, a lot of the work that we do in our lab, both with children with typical development and children with developmental disabilities, is focused on what they know as opposed to what they say.
Yeah, absolutely. And one thing that's also happening these days is the kind of increase in digital device use in homes, which is
Hmm.
also, um, there's a, correlative increase in communication disorders, at least
Oh,
according to the
do you think they're
CDC.
related?
Well, this is actually one of the things that I'm planning to study in my PhD research is
Oh,
the
cool.
effects of digital device use in the home, and the way I think that this might affect language outcomes is
Hmm.
one is kind of reducing the rich interpersonal interaction that is
Hmm.
sort of required for speech and language, but also other um, things like the signal to noise ratio
Yes.
also will change in the homes.
Yes. Oh my
It,
gosh. But that's been true. I mean, TVs are just on in homes, right?
right.
You go into homes, and even before all the digital devices, the TV's just always on, which is terrible for the signal to noise ratio.
Yeah, that is true. Yeah. I think maybe the bigger one with specifically for smartphones is just that, the parent might be on it or, that's distracting
Yeah.
the parent. I also see a lot of, iPad babysitting in
Yes.
which like that language, whatever input that they're getting is not kind of either contextually relevant to the environment that they're in
Hmm.
or like it doesn't require any back and forth or
Right.
it's
There's
like
no contingent responding.
exactly. Like there's almost they're learning these sort of like back to the other things. They're learning these spurious contingencies, perhaps
Hmm.
that are affecting. I don't know what they find meaningful.
I'm curious, as you have more expertise in this area than I do you think, if you think about the parents' use of devices and the child's use of devices, which do you think is more problematic for language development?
I pro I would say that it probably shifts at some point in development. So
Mm-hmm.
in the early stages, it's more like the parents' use of
Mm-hmm.
devices, and like in as the child gets older,
Mm-hmm.
their overuse of device is sort of you know doing a lot of things like
Yeah.
decreasing attentional capacities and yeah, changing sort of their tolerance for boredom, which
Yes,
you
for
do
sure.
need to some degree, and also just I think just decreasing that time in interpersonal interaction where you're getting a
Mm-hmm.
lot of the cues. You're going back to kind of like Thomas Seller research with like joint attention and
Mm-hmm.
intention reading. A lot of those things go away when you're on a device. So I think
Right.
it's reducing, yeah, that rich language input that you need.
For sure. Yeah, I think I'm glad you're gonna do your research in that area. I think it's super important and understudied.
Yeah, I hope that we find something that's helpful for new families because this is not something that's going to go away.
No, for
So
sure not. It's just going to get more and more prevalent, I think.
yeah. And I think context is something that's really, really understudied and kind of undervalued in speech therapy. And you did a paper recently about how like early word learning is influenced by physical environments, um,
Hmm.
specifically with like a difference in shape with these toys.
Hmm.
Yeah, could you maybe describe that a little bit? I think that's such a cool
Yeah.
idea.
Yeah, that was a fun study that one of my grad students, Ellie Breitfeld, did. She was inspired actually by thinking about the children's toy, the shape sorter. I don't know if you've played with shape sorters. Do you know what those are?
I have not.
They're
I'll have
like
to
a
look that up.
they're like a puzzle box that has openings of different sizes in
Oh,
them
okay.
with different
Yes. Yeah.
shapes. And then the
Got it.
kid has like toys of the different shapes, and they have to put the figure out like which piece goes, you drop it into the box through the right hole. So it's a very classic toy. Um, and she got to thinking that it may be the case that the sort of correspondence between the environment, namely the actual like a hole that's shaped for that puzzle piece, that might sort of support the child's encoding of the shape of the object and make it easier for them to learn words. And so she did a really simple study where, well, it wasn't actually simple, but it the design is simple, where she made two different kinds of puzzle boxes. One of them had our shape sorters, one with made up shapes. One of them had a top where the holes were the same shape as the toys, and the other just had an open hole that was like round and all the toys could fit in it. And as objects were put into these boxes, they were labeled. And so each baby would see two objects that were put into the shape sorter where the holes fit the shapes very specifically, and two shapes that went into the shape sorter where there was just one big hole. Um, and what we found was that when we tested the babies afterwards on whether they had learned the names for these objects, the babies actually had learned more or remembered more about the names of the objects that had gone into the very specific shaped holes in the shape sorter. So the naming was all exactly the same. And of course, we counterbalance which objects were in which condition. But what it suggested was that there is an interplay between something as simple as labeling an object and how that object is being used and the environment in which it is observed.
Yeah, that's so cool. Do you think that the goal of the child is relevant to this? So like the is it the fact that the infant had the goal of putting the toy in the
Uh,
slot or
Well, good question. The infants didn't actually play with the toys. They just
oh they
watched the
just
video.
watched.
Yeah. Now,
Oh,
if the
okay.
infants had had a goal, if we gave the infants the toys, then yes, I do think that would matter. But then we'd have a confound, which is they would have spent more time with the objects that went into the specific holes because they
I
would have had to
see.
figure out which ones went where. Whereas with the shape sorter that's just a big opening, they would just plop it in. So we made videos where we controlled for exactly how long baby saw each object before it disappeared.
Got it. Okay, very cool.
So yeah. So, but your question is a great one because I'm confident that that would have made a difference too.
Got it. Yeah. Yeah, I think that this idea of the physical environment, it sort of directs your attention, which is the foundation for
Hmm.
all of this. Even the statistical learning, you have to attend to that thing first.
Hmm.
So that the physical environment really um, it affords different attentional perspectives and things to learn. So it's sort of like opened up this door for me where I was like, okay, wow,
Mm,
this
cool.
is so there's so much that you can do in speech therapy to,
Mm,
you can't, there's so many things that you can't force,
hmm.
a child to do, but you have a lot of agency in how you set up a child's play environment, the home,
Yeah.
um, they're, thinking on not just the physical level, but, the language routines throughout the day,
Yeah.
how you structure their bedtime routine, for example,
Oh, for sure.
things like that. There are all these little things that you can do to help guide them to like what is relevant and these distinctions. So yeah,
Yeah. No, that's great. Um, Ellie did a different set of studies that just came out that I think speak to what you just said as well. This is again with children with typical development. But she taught them, again, novel words for novel objects, but the objects were displayed in different physical locations in a house. So some of the novel objects showed up in a kitchen, and some of the novel objects showed up outside, like in a playground. And then she tested the kids to these were 3-year-olds, I think, to try to figure out what they thought. But nothing was ever said about what they do or anything. Objects just showed up in these different locations. And then she tested them by showing a pair of objects on the screen. So one that had originally been in a kitchen and one that had originally been outside, novel objects. And then before labeling them, the speech that the child would hear would say, so like, I like to eat the, and we looked at whether the kid, before the word even happened, would shift their gaze to the object that was presented in the kitchen.
Wow.
Or I like to throw the, would the kid shift their gaze to the object that was presented on the playground? And they did.
Wow.
So what that tells us was even just seeing these novel objects in these different contexts without highlighting their functions or anything like that led the kids to sort of make a guess about their meaning. They guessed that the things in the kitchen were edible and the things on the playground were things you could throw, even though they had never seen them eaten or thrown.
Wow. That's incredible.
Isn't that cool? I like that
Yeah.
study.
It, it just sort of highlights to me too that the fact or the, maybe it's not a fact, but it seems
Mhm.
like there's everything is connected, all of the
Yes.
all of the sensory modalities and, the context, the baby is having to process all of these things.
Mhm.
And this is going back to when I was speaking with one of the professors that works in Nina's lab at BrainVolts, Dr.
Mhm.
Krisman. She was talking about how bilinguals, there's the second language is never turned off. There's only,
Mm.
every time that one word is processed, and it was a similar paradigm with it was like looking towards certain objects, and
Mhm.
they heard a word in, in an English context in English, but it had a sound that was related to a different language that they knew, and they would,
Mhm.
also look to that object, and and so they're kind of expressing the fact that this language is never turned off.
Mhm.
There's no time where you're not doing any sort of processing of that thing. There's just different levels of inhibition and
Mhm.
yeah. So incredible what the brain is doing.
Truly, truly incredible.
So I was wondering what you think about this is kind of getting to some of the sort of philosophical implications of your work.
Mhm.
And I know that, I think this paper had, a lot to say about, for example, like the nativist sort of
Mhm.
argument of, we have this inbuilt language module and,
Mhm.
there's the poverty of the stimulus, like we can't,
Mhm.
get to language from this poverty of input. But yeah, where do you kind of stand on this argument?
Mhm. It's still something I'm very interested in. I guess so. Sometimes people are surprised when I say this, but I consider myself a nativist, even though I study learning. And I think I consider myself a nativist because I study learning,
Mm,
because we have to come to the world with learning mechanisms, with abilities to learn, to encode, attend to, keep track of information, and that
hmm
has to be innate. Like that has to be built in. But I would consider myself a domain general nativist in the sense that I am not convinced, and I might be wrong, but I've yet to be convinced that any of these things are specific to language when we start out.
mm,
Um, and so that what's innate are our capacities to attend, encode, keep track of information. But I don't know that any of those abilities, including statistical learning, are particular to language, at least
mm,
not initially. As we have more experience with different modalities, sort of like we were talking about at the beginning of the podcast with music and language,
hmm
presumably at some point babies realize that like as they keep track of a bunch of notes versus a bunch of syllables, they might do the same statistics, but they're doing it over different input. And so the output of those processes should be treated differently. Like you're going to dump the output of gola bu pabiku tuti bu into the language box, and you're going to dump the output of do whatever those statistics are into the music box. Um, so yeah, I guess I'm a domain general nativist. And I do think that a lot of the poverty of the stimulus kinds of um, questions have kind of been blown up a bit by all the large language model stuff that does suggest that it's not that there's not enough information in the stimulus, you just need a lot of it. Whether there's enough to account for how babies learn is an open question, I think.
Yeah. Oh, wow. That's so interesting. I wouldn't have expected actually that. So it's cool to find out that you're a domain general nativist. Actually,
For
that's,
what it's worth.
yeah.
Yeah.
Not that labels matter, but
Well,
uh, well, in word learning they do. So maybe, um,
exactly. There you go.
yeah. It's funny because that's how I conceive of sort of think the same way, but thought of myself as on the other side of the nativist argument,
Mhm.
because not that we don't come into the world sort of pre-wired for specific things, but that those things are relatively dependent on experience
Mhm.
in a lot of different ways. Um,
Mhm.
and
Yeah.
but yeah, so it seems like kind of the
Yeah.
same
I
idea.
mean, I think that's what makes it interesting, right? And that's part of why language and music are such interesting things to study. I mean, language has to have a biological component, right? Like my dog is really smart, but he understands maybe 70 words and he doesn't understand any syntax to the extent I can figure it out. So there's something biologically different there. But at the same time, I speak English and a few other languages badly. I don't speak Russian. I don't speak Thai. I don't speak Japanese because I haven't been exposed to them. That's clear evidence of experience, right? So that's part of why I think language, and you could argue something similar about music, right? Um, in the sense that like other species don't have anything like music. They have their own ways of communicating emotion and structure. But there are different musical cultures, and if you are not a native listener of a particular musical culture, you're going to have trouble in processing and encoding it. So I
Yeah.
think these are great places to think about nature nurture because it has to be both.
Yeah. Yeah, absolutely. That's one of my biggest, I just think it's so awesome. Like to me, it just fills me with this like awe and wonder and curiosity that like there
Hmm.
like what is even the intrinsic motivation behind, wanting to vocalize or wanting to imitate or what is a child's reason for, you know,
Yeah.
doing a lot of that stuff.
Or even learning any of this stuff. I mean, why? I mean, we throw babies into a soundproof booth and play Golabu Pabiku to them for 2 minutes. Why do they learn, right?
Right.
It's actually something I'm extremely interested in is what is the motivation? Because it isn't, in the case of the kinds of experiments we've been talking about today, it's not communication. Right? There's no reason why tracking those statistics would happen if it was about communication. I think it's about
Yeah.
something else. I think it's about trying to make sense of the world, trying to make predictions that make sense,
Yeah.
just finding the signal in the noise, something like that.
Yeah. There's a notion in, I think it's dynamical systems theory of like optimal
Hmm.
grip, like gripping the
Right.
world. And so
Hmm.
like across modalities, you're sort of trying to find the best grip on the world. And so
Hmm.
like in like infant vocalization research, for example, you are first you're kind of making these sort of random sounds and they slowly, I think maybe the
Hmm.
first few months or like that is sort of pretty robust to any different experience. But then after that, it sort of starts to depend more and more on your
Right.
language,
That's
your
right.
mother tongue. Um, yeah, yeah, it's the same thing with walking. It's like your movements are so random at first, and then you kind of have you imitate something that you see, and you have a target to sort of start
Hmm.
to.
Your
Uh,
goals change. Like we were talking about goals earlier. Your goals change, I think.
right? Yeah. So, such interesting questions. It's such a mystery. And yeah, thank you for unraveling, this one part aspect of this mystery
Oh
for
gosh,
all
I
of
think
us.
I think all of this work just opens up more. I mean, part of why I love doing this sort of work is I think it just opens up more questions, right?
Yeah,
So instead of ever answering a question, I think every study we've ever done that what makes good science is it leads you to ask questions you wouldn't have asked before. And so that's what I love about our field is that we just keep asking more and more questions that 20 years ago, 30 years ago, 40 years ago, we wouldn't have thought to ask. So I think that's
yeah,
really cool. And that to the extent that it can eventually be helpful to clinicians or parents or kids, like that would be, I mean, that's the hope, right? That's
right.
the long-term goal.
What are you most excited about right now? Any particular questions that you're thinking about?
Yes, actually, and it relates to what I just said about helping clinicians and parents and kids. Hopefully, I collaborate with a lot of my colleagues in our communication sciences and disorders department. And one of my colleagues, Katie Hustad, who studies children with cerebral palsy, she and I just got a new grant that we've been working on for a long time. Um, to take some of the very simple eye gaze methods that we use in my lab to ask what words babies know and use them to try to look at, to study little kids with cerebral palsy who can't talk and can't point and whose parent that for many of these kids the parents don't think they know, have any words at all, they don't think they understand any words, and do very simple tasks where we put images up on the screen and say, where's the shoe? Can you find it? And measure eye gaze. To sort of start asking whether we can actually measure language comprehension and then eventually language learning in kids who have been pretty much impossible to study because they're kind of locked in.
Oh, that's so cool. That's fantastic. Yeah, it seems like you're even with the earlier statistical learning research, all of it is you're illuminating what's going on that like these aspects of learning that we can't see, which is helping people to
Exactly.
understand, right? That they're, you know, even though these kids aren't saying anything, they might know so much more than you expect.
That's exactly right. Like we want to know what's going on under the hood because that really that could really help interventions. In the case of these particular kids, they often can't even get fitted with AACs because they can't really do dwell time kind of, triggering of images or lexemes or whatever. And so being able to use our methods to be able to say, okay, here are words we think this kid knows. So let's go from there. I think would be really exciting. So we'll see where that goes. We haven't started data collection yet or anything like that, but I
Very
love
cool.
thinking about what's going on under the hood.
Yeah. So for all the SLPs listening, do you have an ask of them or any way that we can support if, if people are interested in, reaching out to be part of this effort?
I don't have a particular ask, but if folks are curious or interested, they are always more than welcome to reach out to me. Feel free to throw my email address up on and my lab website up on your page. And yeah, I love getting to talk to clinicians and parents and people who care about kids because we all want to see optimal outcomes for everybody.
That's awesome. And I think that that's an awesome place to maybe stop. And, thank you so much again. You're an inspiration. And,
Oh,
definitely it's just thank you for, yeah, again, revealing part of this mystery of, what lies beyond what we can see. And yeah, any last remarks or conclusions you'd like to leave us with?
thank you so much for asking such wonderful questions and being so engaged and excited. It's a joy to get to talk to young people who really care. It's great.
Ah, I feel the same way. Yeah, thank you so much for your time. And all right, everyone, take care, stay curious, and hope to see you in the next episode.